Welcome students. Today in this video lecture I will discuss on the topics surface tension অর্থাৎ তরলের পৃষ্ঠটান. Now before starting the lecture I want to share some interesting picture with you. This is a small spherical dewdrop. Here these are some small raindrops and these are also spherical in shape. Here you see a needle. It is a small needle. It is floating on the surface of water. অর্থাৎ একটা ছোট্ট সূচ যেটা জলের উপর ভাসছে কিন্তু জলের মধ্যে ডুবে যাচ্ছে না. Here you see this insect. The insect is walking on the surface of water. এটা জলের উপর দিয়ে হেঁটে যাচ্ছে, এটাও কিন্তু জলের মধ্যে ডুবে যাচ্ছে না. Here you see these are spherical bubbles. Now why these bubbles are spherical? Why they are not taking any other shapes like cylindrical or any other shapes? Now behind all these phenomena there is a property of liquid. That property of liquid is surface tension. So surface tension is the property of liquid which is linked with all these phenomena. Now I am studying the topic surface tension. Now what is surface tension? The property of a liquid by virtue of which the free surface of the liquid at rest tries to minimize its surface area is called surface tension. অর্থাৎ কোন তরল তার যে ধর্মের জন্য তার পৃষ্ঠতলের ক্ষেত্রফল সংকুচিত করতে চায় তরলের সেই ধর্মকেই বলা হয় পৃষ্ঠটান. Due to surface tension, liquid surface behaves like a stretched membrane. অর্থাৎ তরলের এই ধর্মের জন্য যে কোনো তরলের উপরিতল একটি টান টান রাবারের পর্দার মতো কাজ করে. যদি কোনো একটা বেলুনের টুকরোকে আমরা পালপিন দিয়ে চারিদিক থেকে টান টান করে রাখি, যেমন সেটা একটা স্ট্রেচড মেমব্রেনের মতো আচরণ করে, সিমিলারলি যে কোনো তরলের উপরিতলই এই ধরনের একটা স্ট্রেচড মেমব্রেনের মতো আচরণ করে. Now how we can measure the surface tension? To measure the surface tension we shall try to define surface tension in terms of force. Actually the property of the surface tension arises due to the intermolecular force. So I am trying to discuss the surface tension in another angle. Now this is a container which is containing some liquid. Now if I consider an imaginary line on this liquid surface, then on the both side of this line there will be some force acting. These forces are perpendicular to the line and these are tangential to the plane of the liquid. Now this force per unit length is called surface tension. So we can define surface tension in another way. If an imaginary line is drawn on the liquid surface, the force per unit length in the tangential plane to the surface and in a direction perpendicular to the line drawn is called surface tension. অর্থাৎ তরলের উপরিতলে একটি কাল্পনিক রেখা টানলে ওই রেখার দুই দিকে লম্বভাবে এবং তলটির সাথে স্পর্শকীয়ভাবে প্রতি একক দৈর্ঘ্যে যে বল কাজ করে সেই বলকে আমরা বলবো পৃষ্ঠটান বা surface tension. So the expression of surface tension is T equal to force over length. The SI unit of surface tension is Newton meter inverse because the unit of force is Newton and unit of length is meter. Similarly, the unit of surface tension in CGS unit will be dyne per centimeter or dyne centimeter inverse. Now the dimension of surface tension, it is given by T equal to F by L, that is mLt to the power minus 2 over length, that's mean mt to the power minus 2. Now I am discussing few examples based on surface tension. As I have already discussed with you, this is a small spherical water drop. Now, the small water droplets or raindrops are spherical in shape. Why? Now, this is due to surface tension. What is the cause behind this? Due to surface tension, liquid surface always tends to minimize its surface area. Since for a given volume, spherical shape has minimum surface area, so any small liquid droplet tends to be spherical. Now here it is to be noted that for small droplets, gravitational force is negligible. If we take large water droplets, in that case the gravitational force will not be negligible, and due to the gravitational force the spherical shape may be deformed. Now another example, when mercury is placed on a clean glass plate, it forms globules. Now it is seen that the teeny globules are spherical. Why? This is also for surface tension. Here also the gravitational force is negligible. If we take bigger globules, then for that we will see this kinds of figure. So for bigger globules, this gravitational force plays a significant role and hence the globules get flattened. So when the gravitational force is negligible, only the surface tensional force is the main force. In that case, due to surface tension, any liquid try to be spherical because for a given volume, spherical shape has minimum surface area. Next, this is another example. Here you see this video first. You see this needle. I am keeping this needle on the water surface, and interestingly, it is floating on the surface of water. Now you know that normally the material of the needle is heavier than water. In spite of that, it is floating on the water surface. Why? This is also due to surface tension. So when a greased iron needle is placed gently on the surface of water at rest so that it does not prick the water surface, the needle floats on the surface of water despite it being heavier. The cause is here, this is the cross-sectional view of the needle. Now the surface tensional force acts along this surface and also along this surface. So for these two surface tensional force, there is a resultant force. This resultant force balances the weight of the needle. So the weight of the needle is balanced by the vertical component of the forces of surface tension. Due to this, the needle floats on the water surface. Now I am discussing cohesive and adhesive force. There exist forces of attraction or repulsion between different molecules. আমরা জানি বিভিন্ন মলিকুলের মধ্যে কিছু আকর্ষণ এবং বিকর্ষণ বল কাজ করে। Now this force may be classified into two types. One, it is cohesive force. Another one, this is adhesive force. Now what is cohesive force? It is the force of attraction between molecules of same substances. অর্থাৎ একই পদার্থের দুটি অণুর মধ্যে যে বল কাজ করে তাকে বলা হয় cohesive force. Here you see this figure. Here this is one water molecule. This is another water molecule. Now the force between these two water molecules, it is cohesive force. যেহেতু দুটো একই ধরনের অণু তাই এদের মধ্যে যে বলটা কাজ করছে তাকে আমরা বলছি cohesive force. Now what is adhesive force? Now it is the force of attraction between the molecules of the different substances. অর্থাৎ দুটি ভিন্ন পদার্থের অণুর মধ্যে যে আকর্ষণ বল কাজ করে তাকে বলা হয় adhesive force. Here this is water molecule and this is the material of the container. Now the force between these two, that's mean the water molecule and the molecule of the container, the force in between them, that is adhesive force. Here also this force is adhesive force. Now some example based on cohesive force. We know that two drops of liquid coalesce into one when brought into mutual contact. অর্থাৎ দুটো তরলের বিন্দুকে যদি কাছাকাছি আনা হয় তারা পরস্পরের সাথে আকর্ষিত হয়ে একটি বিন্দুতে রূপান্তরিত হয়. So this is one example of cohesive force. Similarly, you know, it is very difficult to break a drop of mercury into small droplets. This is also due to the large cohesive force between the mercury molecules. অর্থাৎ the large drop of mercury থেকে যদি আমরা কিছু small drop of mercury করতে চাই বড় ড্রপটিকে ভেঙে, that will be also very difficult. This is due to the large cohesive force between the mercury molecules. Now this cohesive force is very strong in solids. For this strong cohesive force, solid substances have definite shape. অর্থাৎ আমরা জানি কঠিন পদার্থগুলির মধ্যে যে কোহেসিভ ফোর্স কাজ করে তার মান অত্যন্ত বেশি এবং সেই লার্জ কোহেসিভ ফোর্সের জন্য সলিড সাবস্টেন্সের বা কঠিন পদার্থের একটি নির্দিষ্ট আকার থাকে. This force is weak in liquids and extremely weak in case of gaseous substances. Now, few example on adhesive force. We can write on the blackboard with chalk due to presence of adhesive force between them. অর্থাৎ আমরা যখন চকের সাহায্যে ব্ল্যাকবোর্ডের উপর লিখি তখন ব্ল্যাকবোর্ডের মলিকুলের সাথে চকের মলিকুলে যে আকর্ষণ বল কাজ করে সেই আকর্ষণ বলের জন্য আমরা লিখতে সামর্থ্য হই. Similarly, a piece of paper sticks to another due to large adhesive force between the paper and the gum molecules. অর্থাৎ আমরা যখন গামের সাহায্যে একটি পেপারের সাথে আরেকটি পেপার আটকানোর চেষ্টা করি তখন গামের মলিকুলের সাথে পেপারের মলিকুলের স্ট্রং অ্যাডহেসিভ ফোর্সের জন্যই একটি পেপার অন্য পেপারের সাথে আটকে যায় সহজে. নেক্সট, অরিজিন অফ সারফেস টেনশন. What is the origin of this surface tension? I have already discussed with you that the cause behind surface tension is cohesive force. Now, the distance up to which the force of attraction between two molecules is appreciable, that is called molecular range, and which is very small. The range is of the order of 10 to the power minus 7 centimeter. Now, if a sphere of radius equal to the molecular range is drawn, taking a molecule as a center, that sphere is called the sphere of influence. The molecule at the center is attracted only by the other molecules which are within the sphere of influence. Now in this figure, this is a liquid molecule A and this is the sphere of influence. So the molecule A is well inside the liquid. It experiences equal cohesive forces from all sides. Hence, the net force on this molecule is 0. যেহেতু আগেই বললাম যে কোন একটি মলিকুলের চারিদিকে যদি আমরা একটা স্ফিয়ার অফ ইনফ্লুয়েন্স ড্র করি, দেন ওই স্ফিয়ার অফ ইনফ্লুয়েন্সের মধ্যে যে সমস্ত মলিকুল থাকবে একমাত্র তারাই এই কণাটিকে আকর্ষণ করবে. যেহেতু এই বিন্দুর চতুর্দিকে মলিকুলের সংখ্যা সমান, তাই এক্ষেত্রে the force will be equal from all sides and due to which the resultant force will be 0. Now if I consider the molecule B, then what happened? The molecule B is very close to the liquid surface. The number of molecules in the upper half of the sphere of influence is less than the number of molecules in the lower half. So it experiences a net inward cohesive force. Here you see, এক্ষেত্রে এই স্ফিয়ার অফ ইনফ্লুয়েন্সের মধ্যে উপরের পার্টটার মধ্যে কোনো লিকুইড নাই, সো উপরের পার্ট থেকে কোনো অ্যাট্রাকটিভ ফোর্স কাজ করবে না, অ্যাট্রাকটিভ ফোর্স গুলো অনলি এইটুকু পার্ট থেকে কাজ করছে. So due to all these forces there will be a net resultant force. Similarly, if I consider a molecule C here you see the half portion of the sphere is outside the liquid. So from this region there is no cohesive force. the force only acts from this downward direction. So there will be resultant downward force. So molecule C is just on the liquid surface. The upper half of the sphere of influence has no liquid molecule. It experiences maximum inward resultant force. So the molecules which are on the surface of the liquid or very close to the liquid surface experience a net inward force. This force is responsible for the surface tension of liquid. Next, angle of contact. What is angle of contact? The surface of liquid near the plane of contact with another medium is in general curved. Here you see this figure. Here you see this liquid molecule or this liquid is in contact with the solid at this point, and here it is curved. Similarly, here also it is curved. Now, at the point of contact, the angle between tangent to the liquid surface and tangent to the solid surface inside the liquid is termed as angle of contact. That's mean যদি এই বিন্দুতে আমরা তরলের উপরিতলে একটি স্পর্শক টানি এবং যদি সলিডের সারফেসে একটি স্পর্শক টানি এবং এদের মধ্যে যে কোণটি তৈরি হবে, that angle is called angle of contact. Similarly here, this is the tangent drawn to the liquid surface, this is the tangent drawn to the solid surface, and the angle in between these two is the angle of contact. Now the value of this angle of contact may vary from 0 degree to 180 degree. Here in the first case you see, here it is less than 90 degree. In case of water in contact with glass, this is acute angle, and here in this case we see this is obtuse angle, the value is greater than 90 degree. In case of mercury in contact with glass, the angle will be obtuse angle. For different pair of liquids, this angle will vary between 0 degree to 180 degree. Next, capillarity. Very interesting topics, capillarity. What is capillarity? Now, if a tube of very small inner radius, the tube is called capillary tube. Now, this tube is dipped in a liquid. It is found that the liquid in the capillary tube either rises or falls relative to the surrounding liquid level. This phenomena is called capillarity. Here you see this case that the liquid rises up through this capillary tube. When this happens, now if the angle of contact between the material of the tube and the liquid is acute, অর্থাৎ যদি স্পর্শ কোণটার মান 90 ডিগ্রির চেয়ে ছোট হয়, then the liquid will rise up through the tube. This is called capillary rise. Next, capillary fall. Here you see the liquid level has fall down. When this happens, if the angle of contact between the material of the tube and the liquid is obtuse, অর্থাৎ যখন স্পর্শকোণের মান 90 ডিগ্রির চেয়ে বেশি হয়, তখন লিকুইডটি উপরে ওঠার বদলে নিচের দিকে নেমে যায়. Then the liquid will fall down to the tube. This is called capillary fall. Now the formula for the capillary rise, it is given by H equal to 2t cos theta over r rho g. H also may be the amount of capillary fall. I am not deriving this formula because it is beyond your syllabus. Here H is the height of the capillary rise, T is the surface tension, theta is the angle of contact between the liquid and solid, R is the inner radius of the capillary tube, rho is the density of the liquid, and G is the acceleration due to gravity. So we are getting H equal to 2t cos theta over r rho g. From this formula, it is clear that for a particular pair of liquid and solid, H into R equal to constant. Why? Because you see, for a particular liquid, T is constant. For a particular pair of solid and liquid, theta is constant, density of the liquid is constant, acceleration due to gravity G is also constant. So the product H into R, that will be constant. So H into R equal to constant. Therefore H is inversely proportional to R. So we may write the ascent or descent of a liquid in a capillary tube is inversely proportional to the inner radius of the capillary tube. অর্থাৎ তরলের আরোহণ বা অবরোহণ কোন টিউবের মধ্যে টিউবের ব্যাসার্ধের সাথে ব্যস্তানুপাতে পরিবর্তিত হয়. Now this is Jurin's law. Now what happen in case of a capillary tube of insufficient length? That's mean if I take a capillary tube of length n which is less than the normal capillary height h, অর্থাৎ সাধারণত যে হাইট পর্যন্ত তরল উপরে উঠে আমরা যদি তার চেয়ে কম দৈর্ঘ্যের কোনো ক্যাপিলারি টিউব নেই তাহলে কি ঘটবে? Will it overflow from the upper end of the tube? The answer is no. In case of a capillary tube of insufficient length, the liquid will not overflow from the upper end of the tube. It can be shown that small r equal to capital R cos theta. Smaller is the inner radius of the tube and capital R, it is the radius of curvature of this liquid meniscus. অর্থাৎ জলের উপরিতলটা আমরা দেখতে পাচ্ছি এটা ফ্ল্যাট নয়, it is curved. Now the radius of curvature of this meniscus is capital R. So if I put this in this formula, then I will get H equal to 2T over capital R rho G. Therefore H into capital R will be constant. That means the height of the capillary rise into radius of curvature of the liquid meniscus is constant. From this we can explain the phenomena why the liquid will not overflow from the upper end. After reaching the upper end of the tube, the liquid will increase the radius of curvature of its meniscus. That means here initially this was the position of the liquid meniscus. Now when it reaches, here you see that the height of the capillary tube ends here. Now before overflowing, the liquid will rises up. As it rises up, then the radius of curvature increases. The radius of curvature will increase gradually till the product of the new radius of curvature and the available length L is equal to the product H into R. That means this will again increase. And finally, when these two are equal, that means H into R equal to L into R prime, where R prime is the new radius of curvature of the liquid meniscus. So when the product becomes equal to the previous product, then the liquid will not rises up again. That will stop at that point. Next, surface energy. What is surface energy? The molecule on the surface of liquid experience a net inward force. Already আমরা কিছুক্ষণ আগে বলেছি যে all the liquid molecules are attracted by other liquid molecules by cohesive force. So all the liquid molecules experience a net inward force. So to bring a liquid molecules from the interior of the liquid to the free surface, some work is required to be done against the intermolecular force. This work will be stored as potential energy within the surface of the molecule. অর্থাৎ যখন আমরা কোনো লিকুইডের মলিকুলগুলোকে তার ভেতর থেকে বাইরে আনার চেষ্টা করব বা পৃষ্ঠতলে আনার চেষ্টা করব, তখন আমাদেরকে কিছু কাজ করতে হয়। সেই কার্যই তার মলিকুলগুলোর মধ্যে স্থিতিশক্তি হিসেবে সঞ্চিত হয়ে থাকে। Now, the potential energy of the molecules per unit surface area is called surface energy. It can be shown that the work done or total potential energy is equal to the surface area into surface tension. অর্থাৎ মোট স্থিতিশক্তি তার ক্ষেত্রফল এবং পৃষ্ঠটানের গুণফলের সাথে সমান। So from here I can show that surface energy per unit area will be equal to capital T. That's mean surface energy per unit area is numerically equal to surface tension. Unit and dimension of surface energy. From this it is clear the unit will be unit of energy over unit of area. That's mean the SI unit will be joule over meter square and CGS unit will be arc or centimeter square. And the dimension will be dimension of energy over dimension of area. So this is ml square t to the minus 2 over L square. So this is m t to the power minus 2. Here it is to be noted that the dimension of surface energy and the surface tension are same. Now from this expression we can define surface tension in another way. The work done per unit area or surface energy per unit area of a liquid is called surface tension when the temperature remains constant. Now some numerical problems based on surface energy. Calculate the work to be done to increase the radius of a soap bubble from 2 cm to 3 cm. The surface tension of soap bubble is given, it is 39 per centimeter. What will be the answer? Now the surface tension of the soap bubble is given, it is 39 per centimeter. The initial radius is R1 equal to 2 cm, final radius is R2 equal to 3 cm. Therefore, increase in surface area is delta A equal to 4 pi R2 square minus 4 pi R1 square into 2. Why this 2 is multiplied? 2 is multiplied for 2 layers of the surface, inside and outside surface. When you consider a soap bubble, then there is an inside surface and there is an outside surface. We have to consider both of these two surfaces. Therefore, this 2 is multiplied here. So, the work done will be delta A into T. So, if we put all these values gradually, then we shall get it will be 3768 arc. So, this is the procedure how to solve these kinds of numerical problem. Now, another example. A drop of water of radius 1 mm is divided into 8 small droplets. Calculate the work to be done in this process. Surface tension of water is given, it is 72 dyne per centimeter. Now how to solve this kinds of question? Now first you see the radius of water drop is given, this is 1 mm, that's mean 0.1 centimeter. Let the radius of each small droplet is small r. Therefore, 4 by 3 pi capital R cube must be equal to 8 into 4 by 3 pi small r cube. That's mean the volume of the large drop will be equal to the total volume of the small droplets. So from this calculation, we can easily calculate the value of this small r. It will be 0.05 centimeter. Next, work done equal to T into delta A. So from this calculation, if I simply put the values, then we shall obtain the answer as 9.04 arc. So in this way, we have to calculate these kinds of numerical problems. Next, what are the factors which affect the surface tension of a liquid? So factors affecting surface tension. Surface tension of a liquid depends upon the following factors. Number 1, temperature. The surface tension of almost all liquids decreases with a rise in temperature. It is seen that at a particular temperature, the surface tension of liquid becomes 0. That temperature is called critical temperature. Now, the surface tension of all liquids decreases linearly with the rise in temperature when the temperature difference is small. And it is given by this formula where this is the surface tension at temperature small t, this is surface tension at 0 degree centigrade, and the relation is given by this expression. Next, surface tension also depends upon the impurities. The presence of impurities either on the liquid surface or dissolved in it considerably affect the force of surface tension. Number 1. If a liquid contains inorganic soluble substance, then surface tension of the liquid increases. অর্থাৎ যদি কোনো অজৈব পদার্থ কোনো তরলের মধ্যে দ্রবীভূত অবস্থা থাকে তবে তার সারফেস টেনশন বৃদ্ধি পায়। যেমন if sodium chloride is dissolved in water, surface tension of water increases. Next, if a liquid contains dissolved organic substance, then its surface tension decreases. For example, surface tension of soap water is much smaller than pure water. The value of surface tension of pure water is 72 dyne per centimeter, whereas in case of soap water it becomes 30 dyne per centimeter. Some impurities which do not dissolve completely in the liquid decrease the surface tension. For example, presence of oil or fat in water reduces the surface tension. Again, presence of chalk dust in water reduces the surface tension of water. Next, presence of electric charge. Due to presence of electric charge on the surface of a liquid, the surface tension of the liquid also decreases. Next, the medium above the liquid surface. The surface tension of a liquid depends on the nature of the medium presence above the liquid surface. For example, surface tension of water with dry air above it, it is 72 dyne per centimeter, whereas with moist air above it, surface tension decreases to 70 dyne per centimeter. So we can see surface tension varies with different parameters. Now, few applications of surface tension. First, we know that the surface tension of soap solution is less. That's why it can spread over large areas within the clothes and it can wash the clothes effectively. Next, if the soap solution of warm water is taken, surface tension decreases again due to the increase in temperature. So washing of clothes become more easier. So these are some common examples in your daily life. You can easily understand this. Next, surface tension prevents water from passing through the pores of an umbrella. অর্থাৎ ছাতার কাপড়ের ছিদ্র দিয়ে জল কিন্তু কখনো ভেতরে ঢুকে যায় না, তার কারণ হলো সারফেস টেনশন। Next, antiseptics like Dettol have low surface tension so that they spread faster. Next, insects can walk on water surface due to surface tension of water. So all of these are examples of surface tension. That's all for the day. Thank you.